Guys, so now let's look at question 23 and 24. Question 23 says, given that S subscript n is equal to the sum from I is equal to 1 to n of 1 on I minus 1 on I plus 1, they're asking us what is the sum or the limit as n tends towards infinity of S subscript n. As it is right now, S subscript n, we can't really find the limit of it, right? So what you should notice is that this, is the summation with a function f of, in this case, f of I minus f of I plus 1, right? From the time I see this summation of these two terms, right, f of I minus f of I plus 1, once you see that form setting up, or sometimes it could even be f of I plus 1 minus f of I. Sometimes that is be set up too, right? But in this case, right, there's your setup here. You should be thinking method of differences. And with method of differences, you need to list out a few terms, and you would see certain terms will cancel off, and it would leave you back with the formula for the sum of the n terms. And then we could find the limit as n tends towards infinity. It will make it easier to find the limit. So let's do that. Let's use the method of differences. So we have S subscript n is given by the sum from I is equal to 1 to n of 1 on I minus 1 on I plus 1. So using the method of differences, let's plug in, or let's look at the first term, second term, and then we'll look at the second to last term and the last term. So the first term would be when I is equal to 1, so that would be 1 on 1 minus 2, right? Well, 1 on 2, sorry. Plus, when I is equal to 2, you would have 1 on 2 minus 1 on 3, right? So you see what we do in there when I is equal to 1 here, right? That's how you get this. When I is equal to 1 here, that's how you get the 2, right? Because the 1 plus 1 is 2. So just make sure you understand that. So this is what we have here, plus dot dot dot. Right, now let's look at the second to last term, which is the n minus 1 term. So that replace I with that, you would get n minus 1 minus 1 on this would just be n, right? If you plug in n minus 1 here, the 1s will cancel off. And then we have this is plus 1 on what? N, the n term we're looking at, right? So we substitute an n here and here. So you would get this here. And the nice thing about method of differences is that you would see a set of terms would cancel off with each other. That is the real nice thing. So this will cancel off with this, right? Because negative, positive is understood there. So here as well, here, and it will have a third inside here. This will cancel off with something in here. This will cancel off with this. And you're left behind with what? This here and this here. So in the end, your S subscript n would just boil down to what? S subscript n would boil down to 1 minus 1 on n plus 1. Right? And now this, to find the limit as n tends towards infinity of this is so much easier. So that's what we could do now. We could say that the limit as n tends towards infinity of S subscript n is equal to the limit as n tends towards infinity. Because we know S subscript n could be written as this, we could put the limit on that, 1 minus 1 on n plus 1. But what you notice is that the limit as n tends towards infinity of 1 of a constant, right? It would remain the same, the constant would stay the same. So this is the same as 1 minus the limit as n tends towards infinity of 1 on n plus 1. Because this function has n in it, the limit will be applied onto it as n tends towards infinity. Right? If you plug in infinity here, the denominator will become greater, bigger and bigger and bigger and bigger. And because it's a fraction, right, as the denominator increases, the whole fraction itself decreases and it tends towards 0. So that is the whole concept behind this. And you'll notice this will turn to 0 and ultimately be 1 minus 0. So your limit as s tends towards infinity, right, of this guy here right? Or you limit as n tends towards infinity of s subscript n would be equal to 1, right? Which is C is the answer there. So that's the solution there, right? For that one there. Let me just make this a bit smaller, right? I hope it's clear. Right, so let's look at now the part 20, not part 24. Let's look at question 24. We have the coefficient of x to the fourth in the Taylor series expansion of f of x is equal to cos x about x is equal to 0 is, they're asking us for the coefficient, right, of the, right, the x to the power of 4 term in the Taylor series expansion of f of x is equal to cos x about x is equal to 0. From the time you see Taylor series, right, you're probably thinking the formula for the Taylor series, but notice this, it is centered about x is equal to 0, which is, right, a special type of Taylor series which is called the Maclaurin series. So we could actually use the Maclaurin series. What is the Maclaurin series? F of x is equal to f prime, or rather f of 0 plus f prime of 0, or rather x by f prime of 0 plus x squared on 2 factorial by f double prime of 0 plus x cube on 3 factorial by x triple prime of 0 plus x4, right, x to the power of 4, right, on 4 factorial by f to the 4th derivative, right? And this is your Maclaurin series, special type of Taylor series centered at x is equal to 0. What they're asking us is for the coefficient of the term in x to the power of 4. Right, this is here, x to the power of 4. The coefficient is this here, right? Is basically, if you pull it out, is the same as 1 on 4 factorial, which is 1 on 24. That's what you notice. Right, you can check it out in a calculator. It's the same as 4 by 3, sorry, by 2 by 1, which would give you 12 by 2, which is 24. Yeah, so I'm just checking it out there. So these answer there for question 24. You don't even have to actually differentiate this, right? Because it's really just a coefficient. If you just could visualize the Maclaurin series, right, and remember this is the coefficient of the term in x fourth, you're good to go, and really recognize that this Taylor series is really a Maclaurin series because it's centered at x is equal to 0. So guys, like the video, subscribe to the channel, right? If you have any questions concerning anything that I did, feel free to drop a comment. I will respond, and yeah, share it to somebody that you believe it will be beneficial to. With that said, I'll see you in the next video.